two of the most confusing and, shall I say, overrated aspects of a stone are the stone's polish and symmetry. Why overrated? Not because they're not important, but because there's maybe too much important stress on them relative to the other attributes of the stone. What are polish and symmetry? Polish refers to the stone's overall polish. A diamond is actually not like a piece of glass. It actually has a grain to it. If you think of a piece of wood, and if you wanted that wood to be smooth, you would polish it down. And you'd polish it and try to kind of fight the natural grain of the wood. Diamonds are very similar in that respect.
A few microscopic polish lines may be of no relevance. But if you are considering buying a flawless diamond, then ideal or excellent polish should be a consideration. If the polish is rated fair or poor, visual performance may be noticeably reduced. In looking at the picture of the diamond under 30 power magnification, in light blue you can see what polish lines look like.
Bankers in the old days, before there were diamond and CV testers, had to test the diamond in a different way. And they actually used the diamond's polish to their advantage. The fact that the diamond had a grain to it. What they would do is they place a water droplet on the surface of the diamond, and if it was a diamond, the water droplet would sort of stick onto there and get caught in the diamond grain. If it was a piece of glass or a cubic zirconia, the water droplet would actually just shear right off the stone, and they'd know the difference. But polish is something that does not affect the diamond to a tremendous degree, because typically it requires over 30 power magnification to tell the difference between a good, very good, and excellent polish. Polish lines are very small, and today the standard for polishing stones is such that it's very, very rare that you'd find polish ratings which are fair or poor, and you're left with polish ratings which do a terrific job. It is true that polish does add more sparkle to the stone in terms of allowing light to travel through better, but the degree to which it does it is not at all significant when you compare it to what diamond cutting can do, namely what are the table, depth percentage, crown, and pavilion percentages of the stone. The stone's cutting is far more significant in affecting light passage in the stone than polish. Symmetry is a bit different. Also, it is actually a little more important than polish, and still overrated because it's sort of an objective and very tangible rating on the stone. You kind of feel good when your stone symmetry comes in as an excellent or a very good. But the fact is that symmetry, again, is not as significant in affecting the stone's ability to return light as the cutting attributes of the stone. But symmetry is a bit more important than polish, because symmetry pertains to the symmetry by which facets meet. What do I mean by that? The angle in which the pavilion facets are arranged, the angle by which the crown and the crown facets meet. If it's fairly symmetrical or terrifically symmetrical, then the stone would receive a symmetry rating that would be consistent with the degree of that symmetry. Now, why is symmetry important? The symmetry by which the angles of the facets meet allows a diamond to not only return light, but also return light with a beautiful pattern, and return light in a way that is very pleasant, and a way that allows the beholder to really enjoy the stone.
In the real world, very few diamonds are perfectly symmetrical, but symmetry is less important to the overall beauty of a diamond than the critical facet proportions. You may never notice any difference between diamonds with ideal, excellent, very good, or good symmetry. In the pictures, the top picture, you will see a diamond that has a good rated symmetry, and the diamond at the bottom has an ideal or an excellent rated symmetry.
The best way that I could think of describing the effect of cut quality versus that of symmetry on a stone is if you take say, two mag lights. You take two very powerful flashlights. One of them more powerful than the other. So you take the less powerful mag light and you shine it on the wall, and it forms a very powerful, somewhat powerful beam. You take the second mag light, and this mag light also shines a very powerful beam on the wall. But this second mag light is, let's say, more powerful, and yet the pattern in which it shines on the wall is not entirely symmetrical. It's somewhat blotchy. There are parts which are parts of that beam which are showing on the wall that are brighter, and parts which aren't as bright, and it's sort of a jumbled mess. But whereas the stone not the stone, but this will pertain to the stone, whereas the mag light that was a little less powerful, that's shown on the wall, that one didn't have as powerful a beam, but it did leave a very beautiful pattern, a very symmetrical pattern of that light on the wall. That would be the difference between a stone which is highly symmetrical and a stone which is very well cut. The ideal would be to combine one and the other. So you achieve a stone that is both has a beautiful pattern and is able to return that pattern with maximal brilliance and maximal light intensity.